All right, so I think this is recording. I'd like to solve three equations in this video. They're all quadratic equations. I know that because the largest exponent on any variable is 2, but I do notice that none of these are in standard form. So I'm going to have to rewrite each of these. And the directions also on this block had said to solve this by factoring. So let's rewrite number 7. Let's take away y squared from each side. So I'll have 8y squared. Let's add 5y to each side. Minus 40y is equal to 0. So I notice here that I have two terms, that these terms have a greatest common factor of 8y. That if I here, let's point it out this one time. Really pointed out that I can rewrite 8 times y squared as 8 times y. You see that I have an 8y as a factor there. I can rewrite this 40y as 8 times y times 5. You can see I have an 8y as a factor there. That factor is common to both terms. If you factor out that common factor from each term, what you have left in the first term is y, and what you have left in the second term is 5. You don't have to do that each time. I just simply wanted to do that because this is one of the earlier homeworks. We'll just skip over that step all of the time from here on in. I have a zero product theorem that says that if you have a list of numbers whose product is 0, then at least one number in the list must be 0. So either it's the case that 8 times y is equal to 0, that's one factor, or this other factor, y minus 5. Divide both sides by 8, or you can easily see that 8 times 0 is equal to 0. Add 5 to each side, or you can easily see that 5 minus 5 is 0. It was a quadratic. The biggest exponent was 2, so we were expecting at most 2 solutions, and we have found them. There they are. So shrink this up, give myself a little bit of room for the next problem. Ooh. How come that's not? Oh, there. Huh. I was trying to shrink it up, but it got bigger. It's kind of neat, but a little bit frustrating. All right, so in the second equation here, again, it's not in standard form. So we've got 5c squared plus 39c minus 8 is equal to 0. I don't see a common factor to these three terms. My leading coefficient is not 1, so this is going to be nice to do this by the x method. For the x method, the bottom of our x is the middle term, and the top of the x is the first term times the last term, negative 40 c squared. And now we're looking for two numbers that when multiplied together give us the top number, but when added give us the bottom number. So if we have 40c times a negative 1c, that should do the trick. If I multiply those together, I get the top value. If I add them, I get the bottom. Now that's trial and error. Sometimes people don't see that. You might have to come over and try some organized scratch work in order to find those two values that you're looking for. Once you have found them, I suggest that you put that information in the form of a table. The first term and last term from the original problem go along one diagonal, and then along the other diagonal are the numbers that you found in your x. It doesn't matter along the diagonal, they're interchangeable, but you definitely want to have them along a diagonal. Here across the bottom, I see that negative 1 is a common factor. Here across vertically here, I see that 8 is a common factor. Negative 1 times a positive 8 is negative 8. Horizontally here, I see that each of these share a common factor of 5c. And vertically here, this just shares a common factor of c. So I can rewrite this equation now into two factors. One factor is 5c minus 1. The other factor is c plus 8. And so now by the zero coefficient, the zero product theorem, that I can split this into two equations. Since these two factors multiply together to give me 0, it has to be true that one of these factors is 0. Either the first one or the second one is representing the number 0. Here, this is a two-step equation. Add 1 and divide by 5. This is just a one-step, subtract 8. Since it was of degree 2, I expect at most 2 solutions, and then we found them right here. All right, so let's take a look at this last one. It's not in standard form. I don't see another squared term, but I do see linear terms on both sides. I'll take away 2a from each side, and I'll take away 5 from each side. So if I haven't done a silly arithmetic error, you have to be careful with signs and arithmetic error. This is what I'm getting in standard form. The directions say to solve this by factoring. So we'll use our X method again. The X method is a very convenient, very nice tool when that leading coefficient is different than 1. Since 2 is a prime number, some of you will be able to do it in your head, and that's fine. But there's nothing wrong with it. Doesn't take that long to do this X method. And then we now want two numbers when multiplied together give us the top, but when added give us the bottom. So 6a and negative 1a seem to do the trick. And now in the form of a table, I'll take the first term and last term from my original problem, and well, after I've written, not the original, after I've written in standard form, and put it along a diagonal. And the two values I found in the X, put that along one diagonal, and now factor out what's common to both of these. A 3 divides both of these values. A negative 1 divides both of these, and positive 3 times negative 1 is negative 3. If I look along here, a is common to both of those terms, and here both these numbers are even, and they both have an a, so I have a common factor of 2a. So you can always check. 1a times 2a gives me the 2a squared. 1a times negative 1 is negative 1a. The 3 times 2a is 6a, and we already said that 3 times negative 1 was negative 3. So that gives us the same equation, but in factored form. And now it's easier to see the solution set in factored form than it is to just look at this and to say, well, gosh, that's obvious. It's that a is equal to 1/2 in 2 steps. A is equal to negative 3. Much harder to see that just by looking at that quadratic equation that's in standard form. Even more difficult the way it was originally given to us. But when you get it in the standard form and you apply this X method and write it in factored form, it is extremely easy to see what the two solutions are. Hope that helps, and I will talk to you later. Bye.